Hi everyone, I am Pranvera Hyseni, and today I want to take you on a little tour of the solar system. Not in a spaceship, but through something much more accessible, a telescope. We are going to talk about what you can actually see when you point your telescope at the planets. I think this is an important conversation because so many people get their first telescope pointed at Jupiter or Saturn and they either go, wow, or wait, what is that? And I get it. After a lifetime of seeing planetary images from space missions, people expect the same high-definition view the moment they look through a telescope. I have been observing planets for over a decade now, and one of my favorite things is helping people understand the difference between seeing a planet in a picture and seeing it with your own eyes. So today, I am going to help set those expectations, share my own observing tips, and show you how to get the most out of your views. By the end of this talk, I hope you will be ready to not just observe the planets, but really see them. And yes, there is a difference. How do planets appear through a telescope? Let's go planet by planet, starting with the ones you can see even with a small beginner telescope. And as we go, I will show you some amateur telescope images so you can compare expectations to reality. Mercury, the hardest one to catch because it's always close to the sun. It's the smallest planet in the solar system, only a little bit larger than our moon. It whips around the sun in just 88 days, but rotates so slowly that a single day on Mercury lasts about 59 Earth days. Because it has almost no atmosphere, its temperatures swing from blazing hot over 400 degrees Celsius in daytime to blazing cold at night. What's especially fascinating is that Mercury is mostly core, a giant ball of metal with just a thin rocky shell around it. Some scientists believe it lost much of its outer core from a massive collision in early history. Despite its closeness to the sun, we have managed to send probes there. NASA's Messenger mission orbited Mercury for 4 years and revealed water ice hiding in craters near the poles, which are permanently shielded from sunlight. Through a telescope, you won't see surface details. It's more like seeing a tiny, bright crescent or half disk, depending on where it is in its orbit. The challenge with Mercury is more about timing and location than magnification. It's only visible shortly after sunset or just before sunrise and always low on the horizon. That means you're looking through a thicker layer of atmosphere, which can distort the view. If you manage to catch it, that in itself is an achievement. Venus is often called Earth's twin because it's nearly the same size, but that's where the similarity ends. Its thick carbon dioxide atmosphere creates a runaway greenhouse effect, making it the hottest planet in the solar system. Over 460 degrees Celsius everywhere, day and night. It rotates backwards compared to most planets and so slowly that one day on Venus lasts longer than its year. The whole surface is hidden under thick clouds of sulfuric acid. Yet, radar mapping has shown us mountains, vast volcanic plains, and evidence that the planet may still be geologically active. Soviet Venera landers in the 1970s and 80s actually made it to the surface and sent back images, but they only survived a few minutes before being completely destroyed by the heat and crushing pressure. Venus is both beautiful and deadly, a world that shows us what happens when greenhouse effects goes out of control. And for observers, Venus is a real crowd pleaser because it is so bright. It's the third brightest object in the sky after the sun and moon. What you will notice is that just like our moon, Venus goes through phases because it is closer to the sun than we are. Same with Mercury. Don't expect surface details though. Its thick clouds hide everything. But those clouds are also what makes it glow so brilliantly in our sky. I remember the first time I saw Venus, it blew my mind because I realized it's not just a bright star in the sky. It's a whole world, part of our solar system orbiting the sun. Mars is our closest Earth-like neighbor, with canyons, volcanoes, and polar ice caps. Its largest volcano, Olympus Mons, is the size of Arizona and 3 times taller than Mount Everest. Billions of years ago, Mars had rivers and lakes, and evidence suggests it could have supported microbial life. Today, its atmosphere is thin and cold, so water can't really stay liquid in the surface, but we know there is still water locked in ice underground. Dozens of spacecrafts have studied Mars, and right now we have several rovers exploring ancient lake beds, drilling into rocks, and searching for signs of past life. Mars is also the planet we're most likely to visit with humans in the near future. And for observers here on Earth, Mars is a favorite for many, but also one of the most misunderstood. When it's far from Earth, Mars is tiny, just a reddish dot. But during opposition every 2 years, when it's closest to Earth, it can reveal polar ice caps, slight surface shading, and sometimes even dust storms. Sometimes these dust storms can grow so large that they blanket much of the planet, hiding almost all other surface detail. When that happens, you're literally watching global weather unfold on another world in real time. Jupiter is the first of the gas giants, which means, unlike the rocky planets, it doesn't have a solid surface you could ever stand on. It's mostly atmosphere and fluid layers with a super dense core buried inside. But if you tried to land there, you'd just sink into thicker and thicker gas under crushing pressure. Jupiter is the largest planet in the solar system, more than 300 times the mass of Earth. It's made almost entirely of hydrogen and helium, basically the same ingredients as the sun. It's like a star that never ignited. Its atmosphere is full of storms that have been raging for centuries. Jupiter spins faster than any planet, completing a day in just 10 hours. Its magnetic field is so strong it creates deadly radiation belts. But what makes Jupiter really exciting are its moons. Europa, with an icy crust and a likely ocean beneath. Ganymede, the largest moon in the solar system, even bigger than Mercury. Io, the most volcanically active world we know. And Callisto, scarred with ancient craters. Each of these moons could be a world worth exploring in its own right. And when it comes to observing, Jupiter is honestly the showstopper. Even in a small telescope, you will see the 4 Galilean moons line up like little beads of light, and at least 2 main cloud belts running across the planet. With more aperture and steady air, those belts multiply into finer details, and you might see delicate blue streamers called festoons and even the famous Great Red Spot. One of the most fascinating things to watch is a moon transit, when one of its moons passes in front of the planet and casts a tiny black shadow. It's a mini eclipse happening hundreds of million miles away. No planet hits you with more wow than Saturn. The first time you see its rings, you don't forget it. Saturn is famous for those rings, made mostly of ice chunks ranging from tiny grains to pieces the size of a house. The planet itself is mostly hydrogen and helium, like Jupiter, but it's so light that its density is less than water. In theory, if you could throw it into a giant bathtub, it could float. Saturn also has over 80 moons, and some of them are truly fascinating. Titan, its largest, has lakes and rivers of liquid methane, a thick nitrogen atmosphere, and a chemistry that may resemble early Earth. Enceladus, a small icy moon, shoots geysers of water vapor into space, clear evidence of an underground ocean that could be habitable. NASA's Cassini mission spent 13 years exploring Saturn, flying through the rings, sampling Enceladus's plumes, and finally plunging into the planet's atmosphere in 2017. And of course, everyone loves looking at Saturn through a telescope. Even a modest telescope will show the rings clearly separated from the planet. Larger scopes can reveal the Cassini division, a thick dark gap in the rings, and several moons, including the largest, which is Titan. I once showed Saturn to someone for the first time. They stepped back from the eyepiece, looked at me, and said, "You put a sticker in there." That's how unreal it feels for the first time. Now we're getting into the ice giants. Uranus is the first planet discovered in modern history. It was spotted for the first time by William Herschel in 1781. It takes 84 years to make one orbit around the sun. To put that in perspective, since its discovery, Uranus hasn't even completed 3 full orbits yet. It won't finish its third until the year 2065. Uranus is an ice giant made of hydrogen, helium, and a thick icy mix of water, methane, and ammonia. It's methane what gives Uranus its bluish-green color. What makes Uranus unique is its tilt, 98 degrees, which means it basically rolls around the sun on its side. That creates extreme seasons. Each pole spends about 42 years in sunlight and another 42 years in darkness. Uranus also has faint rings and at least 27 moons, many named after characters from Shakespeare. We have only flown past Uranus once with Voyager 2 in 1986, so it remains one of the least explored planets in our solar system. On a telescope, Uranus appears as a small bluish-green disk, but without any visible atmospheric detail. Still, there is something profound about seeing it with your own eyes, knowing you're looking at a world almost 2 billion miles away. In a dark sky with a large enough telescope, you might even spot some of its faint moons. Neptune is the farthest planet from the sun, taking 165 years to complete one orbit. Like Uranus, it is an ice giant with a striking blue color from methane in its atmosphere. But Neptune is far more dynamic. Its winds are the fastest in the solar system, reaching over 1,200 miles per hour. The planet has huge dark storms that come and go, similar to Jupiter's Great Red Spot. Its largest moon, Triton, is especially intriguing. It orbits backwards, meaning it was probably captured from the Kuiper Belt. Triton has geysers of nitrogen and is likely to have an ocean beneath its icy surface. Voyager 2 flew past Neptune in 1989, giving us our only close-up look so far. Since then, Neptune has only been studied from a distance by telescopes, and it's long overdue for a dedicated mission. And from here on Earth, it's the farthest planet you can observe from your backyard telescope. So distant that its light takes more than 4 hours to reach us. It's tiny and faint, even in larger amateur scopes, but its deep blue color is unmistakable. With enough aperture and a good condition, you might catch its largest moon, Triton, as a faint point of light nearby. And before we finish, I have to mention Pluto. It's no longer officially counted as a planet, but when I was a kid, it was, and I have always kept a soft spot for it. Pluto was reclassified as a dwarf planet in 2006 because it shares its orbit with many other icy bodies in the Kuiper Belt. But that doesn't make it any less fascinating. In 2015, NASA's New Horizons spacecraft flew past Pluto, giving us our first ever close-up look at this distant world. Mountains made of water ice, glaciers of nitrogen, and even a thin atmosphere that comes and goes as Pluto moves closer and farther away from the sun. Through a backyard telescope, though, Pluto won't dazzle you the way Jupiter or Saturn do. It is so small and so far away that it only appears as a faint star-like point of light. To really confirm you have seen it, astronomers often take pictures of the same patch of the sky on a different night and look for that star that changes position. That shows Pluto slowly moving against the background of distant stars. So while it may not be a planet anymore, it's still out there at the edge of our solar system, and for me, it will always hold a special place in the family of worlds. One thing to keep in mind is that these worlds change. Jupiter rotates in about 10 hours, so its features shift during single sessions. Mars shows seasons, and its polar caps will grow and shrink. Saturn's ring tilt changes over the years. You come back, and often you will not see the same planet twice. That's the basic tour. But remember, your view will depend heavily on your telescope, the atmosphere, and your own eyes. Let's talk about what can make those views better or worse. First, Aperture, the diameter of your telescope's main lens or mirror. More aperture means more light and more resolution, which is great for the planets. But keep in mind, planetary observing is often limited more by the atmosphere than by your telescope size. A huge telescope in bad seeing will perform worse than a small scope in perfect conditions. Second, focal length. This is the distance over which your telescope's optics bring light to a focus, and it plays a huge role in how the planets will appear in your eyepiece or camera. A longer focal length gives you a naturally higher magnification for the same eyepiece, which is why many dedicated planetary telescopes such as Schmidt-Cassegrains tend to have a long focal length, often 2000 millimeters or more. On the other hand, short focal length scopes like fast refractors can still show you great planetary detail, but you will need shorter eyepieces or a Barlow lens to reach the same image scale. When it comes to the type of telescopes, refractors, reflectors, and compound telescopes all have their strength for planetary viewing. Refractors, especially high-quality apochromatic models, give super sharp and high contrast views and require little to no maintenance, although large refractors can be expensive and heavy. Reflectors such as Newtonians and Dobsonians generally offer more aperture for the price, which is great for resolving planetary detail. However, they require periodic collimation, which means aligning the mirrors to keep the image sharp. Poor collimation can reduce contrast and blur fine details. Compound designs such as Maksutov or Schmidt-Cassegrains combine mirrors and lenses to offer a long focal length in a very compact tube. They're great for planets, although they also need occasional collimation and some time to cool down before giving their best view. Which type is best? It all depends on your budget, portability needs, and how much maintenance you're comfortable with. Third, magnification. Planets can handle higher magnification than faint deep sky objects, but there is a limit. Push it too far and the image will blur and dim because you're spreading the same amount of light over a larger area, which makes the image fainter and reduces contrast. I usually recommend starting at around 100-150 times and going higher only if the atmosphere allows. To figure out the magnification you're using, just divide your telescope's focal length by the eyepiece focal length. For example, a 1000mm telescope with a 10mm eyepiece gives 100 times magnification. The same scope with a 5mm eyepiece would give 200 times magnification. Fourth, seeing conditions, the steadiness of the air above you. Turbulent air makes planets shimmer and blur, no matter how good your telescope is. The best views happens when the atmosphere is stable, which is why experienced observers often wait for those rare nights of exceptionally steady air. The higher the planet in the sky, the less atmosphere you're looking through, which also helps. Sometimes just waiting 10 to 15 minutes can give you a sudden pocket of calm air and reveal amazing detail. You can always check the seeing forecast before you go out, because a night with good seeing will show you more details than a night with bad seeing, even in the same telescope. And remember, great planetary views are as much about patience and timing as they are about optics. Fifth, filters. These can help out bring specific features. A red or orange filter can make Mars's surface features pop. A blue filter will bring more contrast on Jupiter's bands or Saturn's rings. And for Venus, a deep violet filter can sometimes show slight cloud patterns. And lastly, your location. Light pollution doesn't really affect planets as much as deep sky observing, but your surroundings still matter. Observing from a spot away from heat sources like rooftops or asphalt can improve clarity, and if you get to a higher altitude site, you may experience steadier air and even sharper views. One of the best upgrades you can make for planetary observing is a tracking mount. At high magnification, planets drift out of the view very quickly, and having to shift your scope constantly to bring the planets in the view can get a little bit tiring. A tracking mount will help you keep the planets centered so that you can focus on the details. Another helpful tool is a Barlow lens, which effectively increases your magnification without needing to switch eyepieces constantly. But if you really want to improve your observing skills, try sketching. It's not about artistic talent. It's about training your eye to notice fine detail. The more you sketch, the more you see. Another cool item that I highly recommend is a biniviewer, which lets you observe with both eyes at the same time. Many observers find that it reduces eye strain and makes fine details easier to see. And then for those who want to go a step further, there is planetary imaging. This usually involves recording a short video of the planet with a specialized camera, then stacking the sharpest frames to bring out incredible detail. It's called lucky imaging because you're taking advantage of those very brief moments of steady air. Planets aren't the same all year round. Use a planetarium app or a sky chart to check when a planet is up, when it's highest in the sky, and when oppositions occur. Planning your session around these times can make a big difference. Oppositions are when they're closest to Earth and appear biggest and brightest. Mars oppositions are especially exciting because they only happen about 26 months. Then there are conjunctions when planets appear close together in the sky. The 2020 Jupiter-Saturn conjunction was one of the most memorable of our lifetime. Also watch for transits, eclipses, and occultations. An occultation is when one object passes directly in front of another, hiding it from the view. Sometimes the moon will pass right in front of a planet. That's called a lunar occultation, and it's an unforgettable sight as the planet suddenly disappears behind the moon's edge and then reappears in the other side. The transit of Mercury across the sun is rare and amazing. Just make sure you use proper solar filters. And then Jupiter-Moon's transits are much more frequent and also spectacular. Here are a few of my best tips from years of experience. Let your telescope cool down to outdoor temperature before observing. A warm telescope gives wavy images, kind of like a shimmering heat you see rising off an asphalt road on a hot day. Large reflectors, Schmidt-Cassegrains and Maksutov-Cassegrains often need 30 to 60 minutes to reach the outdoor temperature. The view gets sharper as internal air currents settle. Observe when the planet is highest in the sky for the sharpest view. Use a steady observing chair and a comfortable eyepiece with a good eye relief. Relax your face and just blink normally. If your eye gets tired, just switch to the other for a few minutes. Don't just glance. Stay at the eyepiece for several minutes. Your eye and brain adapt and will start to see more detail. Keep an observing log. Note the date, time, seeing condition, magnification, and what you observed. Over time, you will see that your skills will improve. The planets are more than just bright dots in the sky. They're worlds, each with its own personality and story. Your telescope is your ticket to visit them, no matter where you are. Whether you are looking at the icy glare of Venus, the rusty desert of Mars, or the swirling storm of Jupiter, you're connecting with a piece of our solar system's history. So go out there, set up your telescope, and let the planets show you their secrets. Thank you for joining me, and I hope that your next night under the stars is unforgettable.